Hey everybody, welcome to Inside.net. I'm your host, Cecil Phillip, and I'm joined by my co-host and good friend, Rodney Littles, the second. I gotta make sure I say that because I want to make sure people put respect in your name.
I appreciate that.
Gotta do it. So I'm really interested about today's conversation because we're gonna be talking about something that I know nothing about, and I'm sure Rodney knows nothing about either. And that's this whole thing about OpenAI and ChatGPT and what does this actually mean for .NET developers? And are these things that .NET developers could use and consume, and should we even care about it, right? And that's kind of what the conversation is going to be about today. And so to help us kind of understand what this world looks like, we have Mr. Michael Washington, who's going to kind of walk us through, right? He's going to hold our hands like babies and like take us through it.
Draw it in crayon, yeah.
Yeah, he's going to help us understand what's happening here. But before we do any of that, Michael, why don't you start off really quickly with some introductions? Let folks know who you are and what do you do?
Okay. Again, Michael Washington. I am a .NET developer. I concentrate mostly on the Microsoft stack. That's kind of been my career. I've started way back. The first computer program I ever wrote was Microsoft Access.
Nice.
I go way back to VB.NET, Classic ASP. It wasn't called Classic ASP back then. Started with when .NET came out with VB.NET, and then I got into C#, and then just kind of stayed throughout the whole thing. I was very involved with .NET Nuke. People may have heard about that, which Sean Walker, the creator of that, now has a project called Octane, which is a Blazor, it's hard to say, version of that. And I'm also involved with that project and a lot of open source projects. Recently, I've concentrated on Blazor, which has really taken things by storm. It allows us to make single page SPA applications without a lot of excessive JavaScript. I also program in Angular, so I'm familiar with that sort of thing. So kind of get the idea of where my technology path comes from. But recently I got excited about ChatGPT, which is created by a company called OpenAI, not to be confused with OpenAI, the standard. But I really got into it and started kind of playing around. I'm currently working on a book for Syncfusion. It'll be a free book coming out in the next couple of months about OpenAI. It'll be called OpenAI Succinctly. And it'll cover how to consume the technologies created by OpenAI in my case, it'll be specifically using Blazor. However, obviously, it'll cover just .NET, consuming it in .NET. And that's kind of what I'm here to talk about today and explain to people, like, what is this thing and why should I care?
Well, Michael, I could tell you we have a lot of questions for you.
Oh, yeah.
A lot of questions for you. But, just like any good story, why don't we start from the beginning, right?
Okay.
And I think more so now, but I think over the past year, we've been hearing a lot about OpenAI and ChatGPT and AI this, and the computers are coming to take our jobs as developers and all this types of stuff. And I've just been curious, like what is this OpenAI thing? You know what I mean? Like, what is it? Like, is it like a company, or is it a standard, or is it a like what is OpenAI exactly?
So OpenAI is a company, and it is a company that concentrates on using artificial intelligence they are doing research and using it with robots and just various things. So they create a number of products. One of the products that you've probably heard about is DALL-E, and I'll show you what that does. It allows you to describe an image, and it'll create that image. It's an original image that it creates. So that's one of their products. Another one of their products is ChatGPT, and it's a very famous product that just came out in, I think, October, November. And it was the first application, the fastest application to reach 100 million users.
Oh wow.
And so that's why you care. That's why we're talking about it, is because of ChatGPT. ChatGPT, the GPT part of it, is the technology that OpenAI pioneered, and that's the thing. So I'm really prepared to talk about two things, which is the GPT technology, what it does and why you should care, and then also I'll cover the DALL-E product that they also create, because while that's kind of based on GPT, it's not the same thing. So I'll explain what the difference is, and then of course we'll cover how you can consume this in your own applications, like where you would consume it, why you would consume it, and that sort of thing. So
Yeah.
so OpenAI, it's a company product.
You know, when I think about those, I guess you can call like those quote unquote viral applications, right? Like Lens AI is a thing that comes to mind as an example. Or what's the other one? Snapchat and all these types of things that, like, I'm guessing are using artificial intelligence to generate images, make your face look like something else. You know what I mean? Put a pumpkin on my head when it's like Halloween, like on all these types of things that it does. And I'm guessing like the technology behind of it is similar to what I'm guessing OpenAI is building. Would that be accurate?
Yes. So there's other companies, and for example, Stable Diffusion is something you've probably heard about. And what Stable Diffusion is, as opposed to DALL-E, they both do the same thing. Okay. However, Stable Diffusion is created by a different company, and their model. So in the end, you're always creating these models, which is just bits and bytes of code. Actually, it's data more. That's better to describe what a model is, data. So the people behind Stable Diffusion, they release their model out in the open. Okay. It's funny because OpenAI originally is supposed to be more open, but then they created two companies. One company is a holding company, and one company truly is kind of open. But and of course they did this huge business deal with Microsoft, which is why I'll be able to show you how we're going to consume some certain things through Amazon. But they are very similar technologies. And there's other companies that do other things. So the reason why I'll be concentrating obviously on OpenAI is because it's easier to consume their product than say other products. Many of the other, and there's tens of thousands of different models created by various researchers out there. A lot of them you would use Python and notebooks to consume their models. So operationalizing a AI solution can be very difficult and be very challenging. And it's not really something that you can just host on your own computer. So for example, Stable Diffusion, I had downloaded it and got all the Onyx models working and the whole thing running on my computer. And it took 15 minutes to create one image. Whereas the samples I'll be showing you, I'll hit the button and within seconds they'll be created. And that's because I'm consuming the model that's hosted either through Azure or through OpenAI. So I know it gets a little complex, but hopefully we can clear some things up in this conversation today.
Yeah. I think another general question for me is, and I definitely want to get into the OpenAI stuff specifically, but like, I think for me, another general question would be, like, we keep hearing about this AI stuff, right? And as a developer, I know one of the things that I personally struggle with is like, well, what am I supposed to do with it? Right? Like I have this data and I trained the data to, like, I don't know, guess my birthday or whatever. Like it does something. But then what are some of the use cases you see folks building with applications that use them? Like, I don't know, maybe Ronnie's a mobile developer. I do back-end stuff, right? Like what are some of the use cases that we can apply this technology to?
So let's back up to the GPT technology, which is the basis of ChatGPT, which is the basis of GPT-3, which is what I'll be able to demonstrate. Right now, they don't have a way for you to consume ChatGPT through your own applications. That'll probably happen in the next couple of weeks. But so I'll be showing you GPT-3 technology. So the question is, what the heck is it, and why should you care? Basically, what the GPT technology does is it creates what we call completions. So actually, let's go. Can you go ahead and switch to my screen?
Sure. I'll put your screen up now. There we go. Your screen's up.
Okay. So here is an application where it's a Blazor application, and I am calling Azure AI, OpenAI, which means it's the OpenAI product, the OpenAI AI model, but my Blazor app is connecting to Azure to get to it, and I'm going to call a completion. So let me see the first example here. I will do this right here. So if I said 7 years ago, so this right here is the speech, the Gettysburg Address.
Gettysburg Address.
Yes. Again, I know probably a worldwide audience, so they're like, what? Okay. Abraham Lincoln, former president of the United States. So if I call a completion here, and there it goes. Okay. So what happened is that I put in 7 years ago. What the model came back with was the rest of the Gettysburg Address,
right?
And it stopped only because there's places where I can say only go this far and that sort of thing. Okay. So that was a completion. How did it do that? And that's amazing. This is groundbreaking technology.
Yeah.
There is no other technology that you could think of before, because you're going to say, well, I could have done a Google search. But
you couldn't. You couldn't.
Right.
Not to do this.
Right. And then you can also do things like you can say, write this as if you are a child, or actually rewrite this as if you are a child. Right. Yeah. And let me just see if
is going to put the E's backwards.
Actually, let me do just another different prompt here that I already have prepared. Issue I would have here sometimes is that if you don't have enough, context, you have to figure out how many tokens you have to indicate how many tokens for that prompt and that sort of thing. So here's another prompt where I'm saying correct this to standard English. Okay, so if we say she went to the market, and then it's able to say she didn't go to the market.
Okay.
So these are two different kind of things. One was a completion that kind of made sense, but this other one, I kind of asked it to do a thing and it did the thing.
Yeah.
Right. So you're kind of like, what?
Yeah.
It's still a completion. It's still a completion, meaning and these are called prompts. Okay. When you prompt the model, it will then, this is the logical completion. If this were the question or the thing, this is the logical thing that comes next. So your question is, how does it do this? And what it does is that they train the model on like everything. It just, all of Wikipedia, all of they have some models that are optimized for code, what they call code completion. It can write original, computer code. So they train the model. So you can go ahead and switch back. So they train the model on pretty much everything so that it's able to, once it can see everything, it can then make inferences and create these completions. And therefore, it's also able to, when you prompt it, it's able to pull things from what it knows. And So therefore, let's go back to why you should care. I kind of think of this technology kind of like when they came out with spell checkers. So, I'm old enough to remember before we had spell checkers. Okay. And it's one of these things of once it's there, you kind of have to use it. The same thing with this sort of technology. So many of our applications that we create, they have a lot of boxes because you need to gather information from people, right? And then you're going to chunk it and then spit something back out. With this technology, we can have applications where you kind of just have a box and you kind of say, what are you trying to do? And this technology allows the human to indicate their intent. What this GPT technology does is it's able to understand language. And therefore, we're able to, understand the language, do this thing. We're still the programmers. We still have to do the thing because it's an idiot. It doesn't really think. I know it seems like it's thinking. It's not. Okay. Like people are talking about how, the Bing chat, which is based upon GPT technology. It's a Prometheus model that Microsoft did that was kind of like it's actually more complex than the chat GPT model. It's like it's going crazy and it's acting weird. No, it's just an algorithm. Right. But that's why I think we should care, is that we're going to start seeing applications where the human doesn't have to do as much typing and as much filling in the box. Why do they have to put their first name in the first name box and their last name in the last name box and their birth date over here? Because it's language and our computer, we can't understand it. Whereas now with ChatGPT, I would just simply say, describe yourself. And they say, I'm Michael Washington, and my birthday is such and such. Boom. And the GPT model would then be able to understand it, put the data in the proper places, and then move on. So that's why I think you should care, is that if you don't do it, the other the architects and developers will, and their applications are going to use this technology. Specifically, if you think about it, so much of our stuff is mobile. And when you're mobile, do you really have time to start typing? No, you're doing that voice thing. As a matter of fact, most of my texts, when I send texts and even emails, I hit the voice button and I'm talking.
Right.
So, but right now when I get into an application, like I have to do an appointment with the doctor's office. Okay, now I got to drop in and I got to start typing whatever. Now it should be just a box and I should just go to the doctor's office. Yeah, I really need to move this appointment to such and such. And I really want to talk to the doctor about this. Go. And please, aren't you guys using GPT technology? Haven't you, you know what I'm saying? What's with the what's with the boxes? What's with the typing? What's with all these buttons? Come on.
Yeah.
Get with it, guys. So hopefully that allows you to see why I think you should care.
You said something a couple of minutes ago that I'm gonna jump back to. So let's go back in the Wayback Machine. I was in the early parts of my career and I was working on a technology called FAST. And so there we go. So you said that this is about language, and what FAST was a natural language parser, which actually became the technology behind the Bing engine eventually. Right. So I was working on it before all of that actually came. Like, it was brand new. Microsoft had just purchased it from a company in Oslo. And at that point, that was like the Chat GPT thing at the time. Right. And it had its limitations. Right. It didn't have a model behind it, even though you were doing like Google type searches to get information out of documents. It wasn't like a true model that you were training. So what this sounds like is just the natural evolution of the search technology, like the Google boxes and the Bing machines and all of these concepts of how we search for information. And instead of having to go out and explicitly search for it, there's an agent that goes and grabs a whole bunch of the information, sticks it in this algorithm, and then you can interact with the result of that, which to me is a lot more intuitive for us.
Right. The biggest thing, I think, because again, I've actually written a couple of books on earlier machine learning technologies and that sort of thing. The big difference between, and that was really good stuff, they had.
Yeah.
Context. Meaning, for example, my Alexa, because I don't want her to start talking over here.
Yep.
You know, it's good for turning the lights on and off and playing music, and ordering some stuff, you know, simple orders, but not, you know, there's limitations. You know, it's good. It's good technology. The difference between here is context, meaning I can have multiple turns where I can say, you know, create a uh, create a 100-word summary with these points. It creates it, and then I can say, okay, now rewrite this as a 10-year-old. Okay, no, rewrite this as more business. Oh, take out that point. So that context, that's the thing that just, and that's, and the way they're able to achieve that is make the model bigger. Really, that's what it comes down to. It just comes down to, you know what? Just make the model bigger. Train
So
it
really
on
one model,
billions of inputs rather than just hundreds of thousands or millions of inputs.
so it's weird that so it's just one big model. Like in my developer brain, I would think that
it's trained on, you know, billions of parameters.
Gotcha.
That's the training. However, the execution of the model, and that's what brings us into two other things, is you can fine tune the model. Okay, so you've got this GPT-3 model and it's good. You're like, this is great. But then you're like, but at our company or my application, there's a couple of specialized things, you know, our factory has various products and the GPT model was not trained on our products, but I want to use this technology. So you're able to fine tune it.
Okay. So like you might have your own jargon or keywords or things that mean specific things, but only internal to you. Then you could fine tune it for those.
So the model will then perform better if you do that. The other piece is called embeddings. And the official description of embeddings is creating vector representations of tokens to determine similarities and positionings. And you're like, what the heck did you just say? A token is kind of like a word, sometimes a word, but it's how the model is able to break down the pieces of language. Okay. And what it does is to get a vector representation of a token. So for example, the word, if I put 4 and 7 years ago, that comes out to probably about 7 or 8 tokens. So the word 4, a vector representation of it would be this number, this series of numbers, 00725, 0,00347, commas, it's this. And then score is another one, da, 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 da. Well, you can plot a vector on a graph and you would see that this is here and this is here. The way that it really clicked with me was a guy explained it with coffee. He goes, okay, and he does it. And I'll actually have an example like this in the book that I'm writing, whereas I'll show how to get a vector representation of the word coffee, a vector representation of the word cream or milk. I'll get a vector representation of the word latte, because a latte is coffee and milk. Yeah. And then when you plot them, you see their positioning. I get a vector representation of dog. It's over here. So you see how the technology, how they're, because remember, it does completions, right? And it's able to use that mathematical representation of the tokens to figure things out. The thing that makes it more powerful, however, is that the way it's able to know that, you know, certain words have different meanings is because when you plot the vector representation of, say, this sentence over this one here, you can see that when they say I'm in the doghouse or it's a dog day afternoon, you see that one's over here, that one's over here. So therefore, if this sentence is over here, then this thing will be here and I will know the context over here versus the thing over here. How is it able to do that? You need to train that model on billions of input, on billions of parameters, so that you can get something that's able to perform at that level. So I came a long way around to explain, to hopefully answer your question on why is this different? Didn't we have this before?
We didn't.
This stuff's bigger.
Yeah.
Which brings us to operationalizing it, which is you got this big model, right? It takes a lot of computing power.
Yeah.
A lot of computing power.
Oh, yeah.
You're not able to just run this thing on your local computer. It's even costing Microsoft and OpenAI. They say some of these queries for ChatGPT cost in like a couple of cents, and you're like, oh, a couple of cents. You're taking so many requests a day. Trust me, it adds up.
Yeah.
So it's kind of expensive.
Yeah.
That's the thing. And that's why to operationalize it, I usually call either Azure to get to the model, or you can call OpenAI directly, and that's what I can show you guys how that's done.
Yeah. So when I was doing fast, just to give it an understanding of like the computing power, right? We had 4 at the time, like this is like 2009 timeframe. We had 4 Itanium boxes, like they were dedicated servers, and it took me 4 whole days, 4 24-hour days to index 1 million documents, right? And you're talking about billions of microtized inputs inside those documents in order to be able to train this model. So the computing power alone, just to be able to produce the model, I mean, has to be amazing.
Amazing. Yeah. So that's it. They just went bigger.
They scaled, right?
Yeah. Just scale. Yeah.
Awesome.
So then when you think about it, kind of going back to what you're saying, it's graph theory, right? Like, and I think about graph theories, I have edges and vectors and things of that nature. And now we're just creating relationships between this information that we're giving it to, right? So we give it information that said, okay, Cecil at Rodney and Michael, right? And they know .NET, right? And then you could write some query, and then we'll be in like that subset of return results as an example, right? So like you said, like the more data you train it on, the more questions it's able to answer, because now it'll follow the graph path.
Yeah.
Right?
It learned. What it learned, it's able to apply to the particular prompt or query that you're currently giving it. But it's able to achieve what it's achieved because of that massive training.
Got it.
So it also sounds like the competitive advantage is how well I can contextualize the inputs that I have, right? Like that's my advantage over another company's, is how many inputs I can take in and how well I can contextualize those vectors to give you a better understanding of how the information is coming to me.
Actually, there's 2 things. So first is, creating the prompts. You're the programmer creating the prompts, and how well you do it, and how you're able to know how to get the model to do what you need to do. That's key.
Right.
The other one is the arbitrage of the expenses. Because if you just say, let me create an account in OpenAI or Azure, let me spin up a model, and I do want to next go over the different models and the pricing of those models. And you just hit it, you're going to start getting some great stuff, right? And then you could bankrupt your company. You don't want to do that.
Let's not do
so
that.
Controlling the cost versus the functionality, those 2 key things, they're coming in. I'm telling you, the cost cannot be ignored. So if I convey one thing during a conversation here, is I want to convey that this is great technology, but it comes at a cost, and I do want to cover how you can control manage those costs.
Awesome.
Okay, so 2 things.
Yeah.
Okay. So Michael, we've been talking about a half an hour, and I definitely want to make sure that we get a chance to see what like a practical implement, what the code looks like.
Right.
Do you mind if we switch over and take a look?
Yes. So the first thing I want to do is let me go to go ahead and switch over.
Yeah, and then while I'm doing that, like as you were talking, and in the early examples, you're talking about the boxes, and I always, every time someone says boxes, I always think about the first 5 or 6 years of my career, and literally all I did was forms over data.
Right.
Literally, company after company after company, like different industry. At the end of the day, it's forms over data. That's what we're doing.
Yep.
And that example you gave of like, oh well, now we can just have one box. And my head was just like, why did we do this like 10 years ago? Like, I really wish we just had one box. But I can see that not only just being an efficient way for developers to be, but I also think about the user experience now. It's going to be so much more efficient for our users also, because now, like you said, like I don't have to like, type tab, and fill out like, I don't know, a big old form and, profile box or whatever, right? And now it's to be more efficient for them to complete whatever it is that we have them trying to complete too.
Yep.
Okay, so your screen's up now. So
okay.
what are we
First thing I want to cover is, because everything I show you, I want to now talk about cost.
Good.
The way the models from OpenAI work is they start off with the letter A and they go to B, C, D. Okay. So Ada is an earlier model. It's less capable than DaVinci, which is the current, model, recent model. But as you see, the price is different. So if I'm calling Ada, it's 0.0004 cents per 1,000 tokens. So remember, I told you a token is kind of like a word, roughly. There's a way you can determine how many tokens something is, but that's pretty cheap. Okay, so you're like, why don't I just use Ada? Well, because it doesn't perform as well as DaVinci for certain tasks. However, it performs great on other tasks. So, and then why would I use Babbage versus Curie? Well, one, you see there's the cost difference, but then one performs better than the other.
Right.
Some current projects that I'm working on, I am finding that there's so much stuff I can do with Ada that I'm down here in this range. Okay.
Yeah.
But DaVinci, while it's not quite as good as ChatGPT, it comes darn close. Again, that's 2 cents per 1,000 tokens. Yep. Okay, so it's not 2 cents per query. It's, if your query has 1,000 tokens, then it's 2 cents. But if your query only has 500 tokens, then of course that would be 1 cent. So kind of get the idea there?
Yeah. Oh yeah.
Okay. And by the way, the price is the same whether I'm consuming it through Azure or directly through OpenAI. The price would be the same.
Got
it. So here I'm showing you how I'm in Azure, and in Azure I've got my GPT-3 playground. I'm able to determine which model I want to call. I have various examples here. Sorry, I know that's maybe a little small, so let's bump that up a little bit there. Yeah.
And so while you're here too, like just a real quick question, let me jump in with. So I know that so there's OpenAI, right? But and then there's this Azure OpenAI.
Right.
Is this like an Azure proxy, or is Azure just
think about it as an Azure proxy? Okay. And you're like, well, why would I want to go through Azure versus going to OpenAI directly? So for example, this right here, I'm actually in OpenAI directly.
Yes.
Bump this up a little bit here. And I've got my account here, and these are my API keys, and I can call the models directly through here. The reason why I like using Azure is because I have all the rest of my application in Azure. So the integration is easier.
So it's like centralized billing.
Exactly. The centralized billing is the big key to me.
That's the key thing. Yeah. But then also, again, the keys and just the integration with the rest of my application. But right, billing alone is the reason why some people would do it. But it's the same thing. So whether or not I'm going through there, the only difference is that right now Azure doesn't have DALL-E. They should have it in the next couple of weeks, but they're always a little bit behind OpenAI. And one of the reasons why they're always a little bit behind is they have even tighter control over ethical AI, which is even to use Microsoft's Azure AI, you have to fill out a form and a human has to approve your use case. Okay. So they do have tighter controls, which, as you see in the news, certain bad, negative things happen. It's actually a good thing.
Yeah.
So the playground, allows me to, like, here it's just saying, if I have this news article, please classify it into, one of these following things, and it comes out with business. So I was using the Da Vinci model, which you saw will cost more than, say, the Ada model. But if I switch back to the Ada model and I run the exact same query, see, it was a little different, right? But some cases it's like, yeah, but still not that bad. So let me bring it up to, so A, B, C. So bring it to Curie, and Curie came up with the same thing as Da Vinci. Yet, guess what? Curie, it's 10 times
cheaper.
Okay, so I just want to, we covered that. Okay, so I just want to
Yeah.
make sure we covered that. That's important.
And I appreciate that as somebody that does indie work, right? Like I could be an indie developer that doesn't pay attention to this price point, and the next thing I know, I've got a
bill,
$2,000-3,000 Azure bill next month.
Right. So hopefully, if we got if our viewers get a thing out of this, they get that.
Pay attention to the money.
Right. You also see there's a bunch of parameters over here.
Yeah.
And again, so you got max tokens, because I want to control how many tokens. And by the way, this token thing, I know it's maybe hard to see down here, but this query was 73 tokens. And you're like, well, is that 73 words? Yeah. So yeah, tokens is kind of yeah. Again, if I was trying to do English to French, again, see, that's 97 tokens. And generate. So certain models, hey, this works fine. So there's that. And then with Azure, you can go ahead and click view code, and that would give you the code that you would need to, say, for example, call the same thing through, an application. And what I've done is I've created, again, pop this up again, on my site, blazorhelpwebsite.com, and I have the links. I created two different articles. The first one is actually calling OpenAI GPT-3 from Microsoft Blazor. This is connecting directly to OpenAI directly. And so first I kind of explain a little bit about it. I talk about, and I'll cover this DALL-E thing next, show some images. But basically, I talk about how you go to openai.com, you can sign up, you get a key, and go to get your key, you grab your key there. I do kind of cover the cost a little bit here, but then, like I said, right now I've shown you some examples. If you're generating images, the pricing is different.
Got it.
But after that, to consume it, just open up Visual Studio, create a new project. In this case, I'll call it GPT-3 Blazor. But again, you could be just a .NET console application. This code will work the same for that. So again, I'm using .NET 7, doesn't matter. Then you grab a NuGet package. There are various NuGet packages you can use, and new ones being created every day. The one that I used in my example was this one, Betalgo. And so I just installed that. Again, this is just a GitHub project, and it's a really good guy. He, he's just a guy creating this and putting it out in the world. The secret, the keys, I was able to get my key, from here. And oops, sorry, right there. Okay. So I just put my key in there. And then at that point, and this right here is just loading the key. And this right here is just the component from the NuGet package. And then I just had this UI where I basically, say, put what you want. That will be in the prompt variable. And then I just have a button that calls this call service. And so this right here says, grabs the key, and then it just calls a completion. In this case, it's saying use the Da Vinci model. This is the prompt. Here, I'm setting the max tokens to 5, so it doesn't get crazy. And that's why the query previously I was showing you didn't work. I didn't have the for what you're prompting, you need to make sure you have enough tokens there.
Yeah.
And then just gets the results, and then I display the result. So creating doing a completion is actually pretty straightforward. So however, that goes back to the prompt, and that's why the playground is good, because if you say, okay, classify this, then you'll get your result. But let's say you're trying to summarize something. So what you put in this box, this is the programming. Yes, you're back to, you got to program this thing properly. And there you are. The other thing I did want to also show real quick is the DALL-E. And that right there is right here.
So I'm guessing DALL-E is another OpenAI product. Right.
Also based upon the GPT technology per se, but it's not considered GPT. GPT, because GPT was for language, whereas DALL-E is using this kind of same technology but training it for images. So here you're able to just, I said Pixar style 3D rendering of a cat riding a horse holding a flag, and if I took out holding a flag part, and I should get, see, so it did it. What you type here is the key thing, Right. So if I took out, actually, if I just took out that there, service. Let's see, which was the new one?
Oh, those last two.
Oh, those, yeah.
Yeah, last two. Yeah. So, and again, like I said, you can put anything here, but I want to be careful because this is live, and there are filters obviously to filter out certain things, but still, I just want to again. Careful. So how was this created? Let's look at the code real quick. What was the page? Simple image, and bump up the thing here. Okay, yeah. So again, I just had the prompt, and and the button, and so this right here was just the default. So whatever the person types in comes in as prompt. But when you call the button, it was again just get the key, and then here, and this is using that NuGet package, is saying I'm creating an image request. Again, I just set the prompt. There's a couple of various parameters here. This right here is actually the size of the image that I want to, and this is controllable obviously here. Some sizes, if you saw back in the pricing thing, the size, you pay a different amount for the size. Yep. However, usually you can take a smaller size, and then they do you can use upsizing it, to make it bigger. And then of course I wanted back a URL, and that's what I then show the person, but I can of course get it back in byte format.
Right.
The user parameters actually not being used, but this is it. And then I have my image result, and then I just simply took that URL and made an image tag, and then showed it. That's it. So if someone says, "Oh my God, I gotta go through a lot of how do I program to make this work?" Yeah, no, it's can you handle this? All right.
It just seems like calling a web service, right? Like it doesn't seem
like
anything.
That's it. No, in the background it is. It's a web, it's a web service. So I mean, I'm just doing .NET because me, I like to, this is my code right here. This
way easier.
It compiles it.
Yep.
I got IntelliSense.
Yeah.
And the other thing is I even have I use a GitHub Copilot, so I can so call call the service. See, so even GitHub Copilot will call the service to create an image. See if it comes up with the code. Yeah, sometimes getting GitHub Copilot to kick in, but some of this code I actually use GitHub Copilot to write for me.
Mhm.
So,
nice.
which is again the same technology. It's a product by OpenAI, GPT, but it was trained for code. So you can go back, switch back, Cecil.
Okay, sure. Yeah, I really like you had said to us earlier in the beginning, I remember that, hey, a lot of the time, sometimes these things take so long to process. But now we can call this API and it'll take a couple of seconds, and you actually showed it to us. And I was like, wow, like, as a developer, I'm just like, oh wow, like it took a second or two to like render 2 images. But then in the back of my head, I'm also thinking, well, these are all original images that just got rendered and generated in 3D and showed on my screen in like a second or two. And that is amazing because that's like, in my head, that's like hours, maybe even weeks of work, right? That just happened like in a couple of seconds. So again, going back to acknowledging the computing power that's behind of that to make that happen so
Massive.
quickly and also accessible via a web service call that makes it look like, again, like I know we're calling Twilio or SendGrid or something, like we're sending email. You know what I mean? Like that's what it looks like.
But the negative, of course, is OpenAI did go down, had an outage 2 days ago, and people were tweeting about how because OpenAI had an outage, 90% of all startups they went down.
That's
you
funny.
can host your own
Version
models
or-
for certain tasks.
Okay.
Okay, so for certain things like translations or let's say you want to turn audio into text, that is a model that you could host yourself because you don't really need something as powerful as GPT for that. Okay,
Yeah.
so Hugging Faces is a company that allows you to host things, AI models, but a lot cheaper. So just note that you don't have to use this for everything, and it might be a good idea not to use it for everything. But there are certain things where if you want to have the latest, greatest application where a person just can say, I want to change my doctor's appointment. I want you to understand everything I say. And I want
Yeah.
that, for that task, you want to call something a GPT model. But for the rest of your stuff, there are other alternatives.
Sure.
Especially at that price point, right? Like, so it sounds like when I need the power of Chat GPT, I've got to pay to play. And if I don't need that power, there are other alternatives that give me the same technology in a more microtized form for what it is that I'm trying to do.
But you do have to, there still is, unless you're using it a lot, even running your own servers cost money. So a lot of what I recommend to people is consume the services through Azure and OpenAI, and also Hugging Faces. You can call it there. Use them until you get to the point where you have enough traffic that you can then host that model yourself. But hosting the powerful GPT, 3.5 and above, hosting those yourself, I do not see that happening. They're too big. They're too big.
Yep.
Yeah, that DALL-E model. Yeah, like I said, Stable Diffusion. Like I said, I was able to run it on my computer, but to do what I just showed you
took 15 minutes.
Like 15 minutes.
Yeah.
But it did it. It did it.
It did work.
And it was a little small one. It wasn't the big one you saw. It was that little postage stamp size image.
Right.
I did it.
That's great. Yeah, it's great.
And I guess, particularly when we talk about the text-based one and not so much so the image-based one.
Okay.
I mean, at the end of the day, it is a web service, right? And so we should still approach it like we do with software.
Right.
You know what I mean? And so I'm thinking things like, oh, well, we could cache the responses, or we could do things to make it more efficient, right?
Yeah.
So again, I think just like everything else, like we just have to be intelligent about it, like how we use it and make sure that we,
They still need the programmers. You see how it's like nowhere in our conversation did we get to a point where, oh yeah, I don't need a programmer anymore. Actually, I need a programmer who understands this technology. That's what I need. So again, it's opportunity. We make good livings. Seriously, there's so many people who work a lot harder for a lot less money. we're paid because we have to constantly reinvent ourselves. We have to constantly take in this new information and understand it. This is why I have a good living.
Yeah.
This is what they pay me for.
Yeah. No, 100%. I agree with you 100%. Programmer's got a program, man. Like, it is what it is.
It's a great life. I tell people, I lead a team and I say to them when we have a problem, like, "Arr!" I go, it is a good life. It really is a good life.
Yeah, I know it is. So Michael, I know you got to go because I remember you said you did have some stuff you had to go take care of. So before we cut it off, is there anything else, any final resources or things you'd want folks to know about, like a way to get started, other things they should pay attention to, stuff like that?
Well, so the two links, I think if a person goes to those two links, they'll know what I know.
Okay.
So I have links in those articles, but I just hope that I was able to convey a couple of things. Number one, to use it is actually easy. So hopefully everyone can come away from this thing going, yeah, wow, okay, that's not hard.
Yeah.
Number two, costs are important. I really hope that part of the conversation came through. So please be careful. But that's true for anything.
Yeah.
If you go and you spin up an Amazon service thing and
you just keep hammering it with
costs, right, you'll get a bill at the end of the month. You're like, well, what happened? Okay, so there's nothing special, but just please be aware of it. And the third thing is, what is this technology? It really does come down to completions.
Mm-hmm.
It's completions, but it's of course able to understand context and language, and that's the thing that makes it different. So hopefully those three concepts, and then after that, I just hope that we as software developers create really great, incredible experiences for our end users using this technology, the way we've used other technologies to create better software for our end users, because in the end, it's the humans that matter. We're here to serve, do our little piece to serve mankind, like my doctor serves mankind by being a doctor, my gardener serves mankind by being the gardener. We are software developers. We serve mankind by delivering software so they can get the things done that they really care about.
Yes. I like to say software is always about people, right? Because without people, then what's the point?
Right. It's all about people and being of service to people. So, and like I said, we've been given a new hammer. You know what I'm saying?
Yeah.
Let's go build great things with it.
Yes.
Exactly. Yeah, I love that. But Michael, again, thank you so much for being on.
Thank you for having me.
I definitely learned a lot, and I'm sure Rodney did too. And hopefully everyone that's watching, hopefully y'all learned some stuff as well. Like those links you shared, I brought them up on the screen as you were talking, so they should be burned in the video. And then I also took note of them, so we can put them into the description after. So if folks want to go back and look at the description and take a look at those are available as well. But with that being said, like that's a wrap, folks. That's the end of the show. Thank you all for watching. Again, this has been another episode of Inside.net. You can check us out here on Wednesdays. And hopefully we'll see you all next time. Okay. Bye, everybody.